Now, let us try to understand how we can represent a linked list programmatically in our computer. Well, in order to represent a linked list, first you have to represent each element of the linked list. Now, these elements, which is represented with this rectangle like this, or this one, or any of these rectangle you can see here. So these elements are alternatively called either node or vertex of the linked list. To represent these vertex in a computer program or in the pseudocode fashion, we can use a class. Why class? Because class can encapsulate more than one items inside. So now if you can lose, so what are the content? What items should we encapsulate inside this class? So if you look carefully, each of these linked list node or each of the linked list element or vertex has two different parts inside. The first part is a data item. Now, this data item can be anything. It can be an integer, it can be a character, it can be a floating point number, or any type of data. And the second part is basically this one, which is an address or a location that is pointing to the next element or the next vertex. In every cases you can see that the second part is pointing to the next element or next vertex. Now, when it comes to represent it programmatically, we have to make use of a self-referential object. Means an object normally called next of the same type of the class. So next is an object of type vertex inside the same class vertex. So that is how you can represent you can point or represent the address for the next node. You can point to the next node. Now, among these nodes, the first node is very special in a linked list. This first node in any linked list must be taken care of separately. Why? Because if you lose the track of this node, you cannot access any of the element inside the linked list. So this node is very special, and in a program normally we depict it using head. So here I have created an object of the vertex class called head to represent this special first node of the list, which is represented as 0 in this linked list. So, and also sometimes many of the operations of the linked list can be made easy or can be made efficient if we can separately track the last node of the list, that is tail, in here or this one. So we will see later that how can use of tail make some operations significantly easy. But for now, these two nodes are very special, the first node and the last node. So now let us try to answer the question like how to access the next node of the head. So well, we have a special node head here in the linked list, but how can I access the next node of the head? It is very easy. So head is a an object of type vertex. Now inside this vertex there is the pointer next to the next element or next node or the next vertex. So you can just use head.next to represent the next element in the list or next vertex of the list. So so in the list 2, let's say list 2, the head node, the data item in head node is A. Now if you want to access this Z, what you have to do is head dot next. Now if you want to access the next element, which is this one, which is identified as P here, so what you can do, you can add another next using just like this. So just by using head.next, you can simply access each of the element utilizing this next element. This next pointer. Now, how can we access the data item inside the head node? That is also very easy. That is simply the head dot data item, and that's how I can easily access the data item inside that list. So just by using these dot operators, we can access anything inside the linked list. Now the actual implementation in a specific programming language may vary a little bit, but in most of the cases it will follow this type of structure in any of the programming language. Now the other question, tail is the last node of the linked list. So what is there next to tail? In the visualization in this picture, there is actually nothing. So how can we represent nothing in the computer? So what we normally say is that the next node of tail, the next pointer of the tail, which is this one or this one, they point to null, which can be visually represented like this. This is called null, or here. So this is how we can represent a linked list in a computer.